Last one, 5-4, transformations of piecewise defined functions. And the biggest thing that we're going to focus on is absolute value, okay? But when we talk about transformations, we're moving stuff up and down or multiplying, okay? Let's take a look at this example here. Cleo takes 3 one-hour classes at a community college. The graph shows the time that she spends in each class. Next semester, though, each class will start an hour later, okay? How will this change the graph? Well, if we're starting an hour later, that 8 o'clock now becomes 9 o'clock. That 9 o'clock becomes 10 o'clock, and then 10 o'clock becomes 11 o'clock. So the graph moves actually in the right direction, okay? How will the graph change if she's taking 2 90-minute classes, one starting at 8:30, and then the second one at 10 a.m.? Well, it actually extends. We're going to move this 8 to 8:30. We're going to go to 10, and then we're going to go from 10 to 11:30. So it does extend things a little bit more, okay? So here we go. When we talk about step functions, we're talking about either moving up and down or stretching. It makes a big difference. Uptown Sandwich Shop is increasing the number of bonus points by 2 in the shop's rewards program. How is the total points awarded for a $3.80 item going to change? Well, now we're increasing our points from 5 to 7. Notice how 1 point for every $1 you spend, but plus 5 bonus points. So notice how the graph all adjusts going up by 2. So notice right there, from 8 to 10 is now the increase because it was originally 8, but now we're going up to 10 because we're going up 2 spaces instead of the 1, okay? So that becomes crucial. Now, how will the total award for a 125 juice drink change if it's decreasing by 2 points? Well, think about this. If it's decreasing by 2 points, okay, you're now instead, it's $1.25. You're going from now 5 to 3 because you're starting at 5. That 5 now turns to a 3 if you're decreasing by 2. So all of these are going to go down by 2, minus 2. Not difficult. Not difficult. Looking at the next page now. This one's important, okay? Remember, the number on the outside, like we talked about from chapter 3, if it's outside, it moves up and down. Notice how with this graph, it goes down 4, okay? This one here, it went up 2, okay? That's for the number outside. So if we were to draw this graph real quick, okay, it's the V graph, it's going up 3, just like that, okay? This X minus 2, it goes down 2, but it still opens upward. Important. If the number is inside, though, it moves to the left and right. If it's negative, it's going to go to the right direction. If it's positive, it's going to go to the left direction. So let's look at this here, X minus 3. I'm going to move 3 to the right, and I draw my V. X plus 5, notice how it's positive. So I'm going to go to the left 5, boop, bop, beep, bop, boop, and there you go. Not difficult at all. You look at the number inside and you figure out how you shift. If it's inside, it's left, right. If it's outside, it's up, down. Not difficult, okay? Remember, these carry V-shaped graphs. So now let's do both. Okay, well, this is right 4 and then down 2, right? Boop, boop, and you open up that way. Okay, left 5, okay? Up 1, boop, bop, there you go. Not difficult. Let's draw this real quick. This is right 1, down 3, boop, bop, right 1, boop, bop, beep, down 3, boop, boop, and your vertex is going to be 1, negative 3. This other one, okay, if I go back up, this is left, wow, why is it doing that? I think it's because there we go, left 2, up 6, okay, let's draw that graph, left 2, 1, 2, 3, 4, 5, and 6, boop, and there you go. And your vertex is negative 2, comma 6. There you go. Now, the slope makes a difference. It's not that hard, right? You just draw the graph and then you draw the slope after that, okay? For this 1/2, you're gonna go based on the vertex, right? You're gonna go up 1 and then right 2, right? Up 1, right 2, boop, there you go. You draw your line going both directions. This negative 4, it's opening downward because it's negative. So I'm gonna go down 4, right? Down 4, right 1, boop, there's your line for both sides. Okay, let's look at this one here. We actually did this last class, okay? This is your slope. Okay, notice how there's nothing there. So I'm gonna go up 3 over 1. There you go. Same thing, up 3, left 1, draw your graph. That's simple. For this negative 1/3 one, very simple as well. Okay, very simple as well. But the slope is negative 1/3. Oh, wow, it's acting up. That's strange. Okay, negative 1/3. There you go. You're going to go from here down 1 to the right 3. There you go. Down 1 also to the left 3. Beep, bop, boop. There you go. You draw your graph. It's that simple. That simple. Okay, one more to go. Okay, and this involves all the aspects of putting everything together. Okay, if we're drawing all this, you know your slope, and your slope right there is -2. Notice this and this. You're going to go left 3, up 4. Okay, so you're going to go left 3, up 4. Your slope is -2. Left 2 over 1. Left 2 over 1. Boop, boop. You draw your line. It's not that difficult. So let's look at this right here, okay? Let's identify the vertex, okay? That vertex is going to be -1, 2. Let's find the slope. We know it's right there, okay? I'm going to go up 3 over 2, okay? That's your slope. We've got our function, and it's an absolute value function. 3 over 2, absolute value x plus 1, and then plus 2. Not difficult at all, but you have to understand where your vertex is, what your slope is, bing, bang, boom, you are done. That is it, okay? That covers everything. Have fun, get to it.